So what is really going on with matter time? Here's a diagram that shows the tendency of, if you can think of it as that, as space collapsing. Instead of expanding in the current paradigm, it makes much more sense. All the forces are attractive. So why isn't space contracting? That's a perfect explanation for charge and gravity force both. So what we have is a case where the collapse of space is what drives charge. And that collapse is synonymous with an exchange of photons, single photons. The same collapse of space results in exchange of biphotons, gravitational symmetric photons, and also it explains repulsive force, because that's a different phase of collapse. And so all of this is very straightforward in matter time. This picture shows the fundamental basic decay line of matter time at 0.255 parts per billion per year. This decay line is not just an invention of matter time, but it follows from the premises. And it comes from a combination of physical constants. So you need this kind of a decay to make charge work and to make gravity work. So this kind of universe decay makes charge and gravity work together. This shows up in the decay of atomic clocks, the decay of the phase of atomic clocks, the decay of pulsars, neutron stars, the decay of the orbit of the moon as it moves away, the decay of Andromeda as it approaches the Milky Way. And so this decay constant shows up literally everywhere. This energy level diagram is a basic fundamental part of spectroscopy and of the spectral view of the universe. So the relative positions of the lines represents the energy levels of atomic hydrogen. These energy levels are largely determined by charge force, not surprisingly. However, buried in the zero, as it were, are the gravitational states of hydrogen. And in particular, the gravity state for two hydrogens. Two hydrogens approaching each other are undergoing two kinds of interactions. One kind of interaction is what's called dispersive, and that's charge dipole-induced dipole. The other kind of interaction is gravity. And there's a certain distance where the gravity force equals the dispersive forces. And that distance is a very important fundamental result of matter time. So the two basic forces, gravity in this diagram on the left and charge on the right, show two really different characteristics in the paths of particles through space and time. On the one hand, relativistic gravity shows a determinate path for a particle or an object through space and time, and determined completely by the initial conditions of the universe at the time the path started. On the other hand, on the right part is a quantum path. A quantum path is full of uncertainty, and each step in a quantum journey is full of uncertainty, as opposed to the determinate nature of gravity forces. So what this means is we're surrounded by the cosmic microwave background, the edges of the universe, and the collapse of the CMB induces the speed of light. The collapse rate is in fact the speed of light, and so it changes over time. No big deal. It's hard for us to measure the change in the universe over time because it's very small change, 0.255 parts per billion per year. However, it's getting very close to being possible. Moreover, there are lots of phenomena that show this decay. And here, finally, is a synopsis of the emergence of space and time from an electron. So, the outcomes of electrons are what space and time emerge from. The radius of electron is related to the charge of the electron. And that sets our ruler for wavelength of light and therefore our displacement in space. The time of the period of the electron spin, TE, is the basis of all atomic clocks. So these two measurements are yardsticks for time and space. And the second dimension of time, TU, comes from the assumption that the action of the universe, the fundamental action of the universe, comes from Planck's constant and the speed of light and the mass of the MAE, the mass of the fundamental ether particle. From these simple axioms, everything emerges.